Hi everyone, myself is Subramanian, working as Associate Professor in the Department of Pharmaceutical Chemistry, SNS College of Pharmacy and Health Sciences.
Hi everyone. In this video we are going to discuss about the halogenation and nitration reactions of benzene. Here we have taken for halogenation we have taken the example of bromination, and the mechanism is as follows. The next step is attack of the electrophile to the benzene ring. That is, already we have discussed about this formation of this electrophile. BR, FeBr3 will be formed. This will attack the benzene ring to give a carbocation compound. So, carbocation intermediate will be formed. The FeBr3 will attack the benzene ring to give the carbocation intermediate with the elimination of FeBr4. So Br, one of the bromine will be added to the benzene nucleus to give the carbocation intermediate. The mechanism behind the bromination of benzene involves three steps. The first step is activation of the Lewis acid and attack of electrophile by the benzene ring, and third one is deprotonation. So first step is activation of Lewis acid, attack of electrophile by the benzene ring, and third step is deprotonation. The first step is activation of the Lewis acid. Here bromine will react with the FeBr3. That bromine will be added to the FeBr3 to give FeBr3, that is Br delta plus Br plus FeBr3 minus will be formed. So here the Lewis acid will be activated, that is Br2 will be added to the FeBr3 to give the Lewis acid that will be activated, that is Br delta plus Br plus FeBr3 minus will be formed. So here the Lewis acid will be activated to give the electrophile. The second step is attack of the nitronium ion. We have seen the formation of nitronium ion. This nitronium ion will attack the benzene nucleus to give arenium ion. So NO2 will be added to the benzene nucleus to give this arenium ion. The next mechanism will be nitration of benzene. This nitration of benzene involves three steps. The first step is generation of nitronium ion, and third one is attack of nitronium ion to the benzene ring. Then this is followed by the deprotonation of the arenium intermediate. So it is having the three steps: generation of nitronium ion, attack of nitronium ion, and deprotonation of the arenium intermediate. The next step is deprotonation. So here this carbocation intermediate will be formed. This carbocation intermediate will react with this FeBr4. This FeBr4 will take the proton, that is hydrogen, from that carbocation intermediate. So that will be eliminated as hydrogen bromide. Then FeBr3 will be eliminated. FeBr3 completely eliminated to give bromobenzene. Okay, this carbocation intermediate that will react with the FeBr4 so that hydrogen, that is deprotonation, will be taken place. That hydrogen will take the bromine that will be eliminated as hydrogen bromide. So which will give the bromobenzene with the elimination of FeBr3. Normally, the nitration of the benzene ring will be carried down in presence of sulfuric acid. That benzene will react with the nitric acid to give nitrobenzene in presence of sulfuric acid. So the first step is generation of the nitronium ion. Here HNO3, that is nitric acid, will react with the sulfuric acid H2SO4 to give protonated nitric acid. So HNO3 will give H2NO3, that is a protonated nitric acid will be formed, uh, which will give the nitronium ion, that is NO2, will be liberated with the elimination of water molecule. So the next step is deprotonation of the arenium intermediate. So here to the benzene nucleus, H will be present, NO2 group will be present. That hydrogen, this hydrogen, that is proton, that will be eliminated by adding this OH SO3 group. So H will be added to the OH SO3, that is bisulfate ion will be present, that will be removing the proton from that arenium ion to give nitrobenzene. So that C6H5NO2 will be formed. This C6H5NO2 will be formed with the elimination of sulfuric acid, that is H2SO4 will be eliminated. So the last step is deprotonation of the arenium intermediate. This arenium intermediate will react with the bisulfate ion, that is OHSO3 will be added to this arenium ion. This ion will take the proton from the arenium intermediate to give the nitrobenzene. C6H5NO2 will be formed with the elimination of sulfuric acid. I hope you could understand the mechanism behind the halogenation of benzene and nitration of benzene. So, thank you.